Analyzing the leading coefficient. So what are we even talking about? All right, going back to this. This is what we call a quadratic function, right? So it's y equals x squared. This is what we call my parent function. This is the main one. Now, if we want to move it, so if I was to take this right here and move it this way, move it this way, move it down, up, upside down, right? If I wanted to do any of that, this is when we start adding stuff to it. So it'd be like plus 10x plus 1. That's the way we move it, okay? If I want to keep it right in the center, it's just a blue. If I want to move it, I have to add numbers at the end, or coefficients, terms. Okay, so let's go back and look at this. All right, so what does it say? Most importantly, you have to know that for a quadratic function, it can be written two ways. So we call standard form when it looks like this. We have ax squared plus bx plus c. So I have three terms, all right? Then we have factored form, which is this right here where we have parentheses around that. This is factored form. All right, so let's take a look at these two examples real quick. I need you guys to look at this area of an enclosure. Can you guys copy this down for a minute, please? Pause the video. All right. And then copy this down. All right, so let's go ahead and look at this. We're just gonna look at these two equations. Here's my first equation right here. Here's the first one. Here's the second one. And then here's my first one. And here's the second one. Based off what we just learned, standard form and factored form, which of these forms right here is 1 and 2? So let's look at this. Here is 1. Does this one look like factored form, or does this one look like standard form? Which one does it most likely look like? And it's going to be standard form, right? So this is standard form. I'm going to put standard up here. Bam. All right, let's label this real quick. This right here is my A, if you guys can write A above that, the -2. This is your B, right? And then what is your C? If we don't have anything there, what represents nothing? That's going to be plus 0. We don't write the 0, but that's what it means. Okay, that's standard form, which means this is factored form. Okay, up here. All right, make sure you get that. Pause the video. All right, next, right here. So here are my two forms up top. What is that, standard or factored? Let's go back out real quick. This one looks like this, factored form, right? Okay, so this is factored form. And then this one has to be standard. All right, now that we know this is standard, let's go ahead and label my A, B, and C. This is gonna be my A, that's my B, and that's my C. All right, those are your values. We're gonna learn more about them in a minute and what they do. All right, next, here's the first question. What does the leading coefficient tell you about the graph? What is the leading coefficient? That means, what does the number in the very front, what does that tell you about the graph? So let's look at this. What is the number in the very front of this one? This one is a -2, so it's a negative number. And then this one is also a negative number. All right, so when the coefficients are negatives, look at your graph. It's upside down, right? It's upside down. When it's positive, remember this is our original one. Here's x squared. Look, it's a u. So that's the difference between that. So here's what we're going to do. We're going to say positive A gives me my original graph. A negative A value gives me an upside down graph. All right, and then if we have a positive A, this point at the very, very bottom, what is that? It's called a minimum. This point at the very, very top, what's that? It's called a maximum. All right, next. What does it say? How can you determine the y-intercept of the graph using standard form? All right, so let's go back and look at this for standard form. What is my y-intercept for this graph right here? Here's my y-intercept. Now, look at my equation. Notice the very last number, your C value, is always going to be your y-intercept. Let's go check over here. What's my y-intercept over here? My y-intercept is 0. Isn't that my very last number, 0? Yep. So my y-intercept will always be my C value. So we'll say C value is your y-intercept. Copy that, please. All right, let's jump to the back. Bam. So we're going to do these real quick. So it says determine the form of the equation, whether the quadratic form has an absolute maximum or minimum. All right. So remember, positive a value, it's a u. Negative a value, it's an upside down u. So this means positive a value has a minimum, negative a value has a maximum. So let's run through these real quick. Here's my a, here's my b, here's my c. My a is positive, so that means it's going to have a what? A minimum. All right, negative 1/2. What do you guys think that is? That's a maximum. The very first number, my leading coefficient, what is that one? It's positive 1/3, so that means it's going to have a minimum. Negative 2, what is that? It's going to have a maximum. This is a negative number, even though it's a really small number, it's still negative. It's going to have a maximum. And this is a negative 2x, so it's going to have a max. So that's an easy way to do it. And if you were really unsure about, man, I don't remember how to remember, you wouldn't remember how to memorize everything, you would take it to Desmos. So for example, negative 2x, right? Where's my Desmos? Bam. All right, you would type it in, negative 2x, and you would see, oh, don't forget the squared. You would see it's upside down. Okay, that has a maximum. All right, cool. All right, next page. Axis of symmetry. So we're on page 685. All right, next. So it says the vertex of a parabola, what is my vertex of a parabola, right, is the lowest or the highest point on the graph. The axis of symmetry is the line of the parabola that is vertical and passes through the vertex and divides the parabola into two mirror images. Okay, so on your graph right here, so you're looking at this and you're like, okay, where can I draw a line to cut this directly in half? So here's my line real quick, right? Go bam, bam, let me draw a line. I'm gonna take this line and figure out where is it cut right in half. I would say right here. Okay, so this right here is gonna be my axis of symmetry. So your axis of symmetry is always an equation. It's x equals whatever x value I'm crossing. What is that value right here? It's gonna be a 25. So this is your axis of symmetry. You gotta write this down, please. Bam. Okay, if that's my axis of symmetry, what is my vertex? Here's your vertex. What's your x comma y for that? So it's going to be 25, right? Because that's this number. What is your y value right here? I don't know. We're going to say 1250. I'm just kind of guessing. All right. Notice your axis of symmetry, this number right here, your x value is always going to match your x value for your vertex. It should always be the same. All right. Analyze the symmetric points. Yeah, what do you notice about the y coordinates of the points? Okay, what do we notice about the y coordinates? Let's look at my y coordinates. So look at this point right here and this point right here. Right, these are mirror images. This y value is going to match this y value. So this one right here, it's on the exact opposite side. So this y value should match this y value. All right, so then, good job. Okay, how do the x coordinates of each symmetric point compare to the x coordinate of the vertex? So this line right here, let's look at the x coordinates. That's this number, this number, this number, this number. Let's figure out how many spaces away or what distance away is the x value from 25. Can I pull up Desmos real quick? Oh no, it doesn't let me do it. All right. Ooh, let me get rid of some of this stuff. All right, so if I wanted to figure out, hey, what's the distance from here to here, right? Because it needs to be the same distance from here to here. What do I need to do? I need to subtract. I'm going to figure out, okay, what am I currently? I'm at 40. So let's do this one. So 40 minus 25 is equal to what? It's going to be 15. It's a distance of 15. All right. Sorry, I got lost for a minute. All right, you're like, what's going on? Yep. So from here to here, this is 15. All right, well, what's the distance from here to here? Well, if I'm starting at 10 and I want to be at 25, what do I have to add? I have to add 15. And 15 plus 10 is 25. All right, so that's good there. All right, we're gonna jump to the next part. Let's see, what do we know about the mirror images? Axis of symmetry, we can already figure that out. Jump into this next part right here. Absolute, okay. We need to talk about interval increase and decrease. We'll jump to these examples. Can you guys go to this page now? I need you to go to page 688. And we'll finish on this page right here. All right. So we need to identify a few things. So it says for each function, identify the domain, the range, x-intercepts, y-intercepts, axis of symmetry, vertex, interval of increase, which I'll explain, and interval of decrease, which I'll explain. All right, domain. Based off this graph right here, can I draw a line here and say it stops? Nope, that's going to negative infinity. Can I draw a line here and say it stops? Nope, that's going to positive infinity. All right, put the x in the middle. So that means bam, bam. So that means you got negative infinity to positive infinity, and then bam, which is also known as all real numbers. Cool. All right, next, what's my range? How high and how low do you go? All right, let me erase this real quick. Bam, bam. All right, so can I draw a line here and say it stops? Nope, that means it's gonna go all the way down to negative infinity. Is this the highest it goes? Yep, to 2. All right, so my range is going from negative infinity to 2. Range is y, bam, bam, bam. All right, next. What does the next one say? What is my x-intercepts? My x-intercept is bam, bam. These are my x-intercepts. These are also known as my what? My zeros. Right? These are my zeros or my roots. Oops, sorry. That's my y-intercept. So I put roots. When we write these, we're going to write these as points. Okay, so let's write this real quick. So this point right here, what is that point? That's going to be 0, 0. What is this point right here? This is 0, 2. Okay, those are my x-intercepts. All right, let's identify my y-intercept. Where's my y-intercept at? Bam, right here, right? It's where my graph touches my y-axis. It's the same thing, right? My y-intercept is going to be the same thing as my x-intercept in this case. All right, next, what is my axis of symmetry? Where can I cut this bad boy straight down the middle? Right here. What x value am I crossing? Right here. That's going to be x equals 1. Okay, what's my vertex? My vertex in this case is a really high point. It's going to be what? This point right here is 1, 2. All right, here's the last part. It's your interval of increase and decrease. All right, your interval of increase, how high? So we're talking about basically where does your graph go all the way to the top, its max? It's always going to be at this vertex point. So your interval of increase starts here and it goes all the way up and it stops right here. That's your interval of increase. And we're going to write this in inequality notation. So we're going to say, okay, well, what are these values right here? All right. So like basically I'm taking the domain twice. So what is my domain here? Can I draw a line and say it stops here? Nope. That's going to go to all the way to negative infinity. Can I say it stops here? Because is that where it stops increasing? You're like, yeah, well, what's this x value right here? Well, that's 1. Okay, since we're done with that, bam, bam, bam. We never reach infinity, so there's no equal to. We are going to be equal to 1. All right, that's my interval increase. Here's my interval decrease. It starts declining right here. So it's going to start here and go all the way down. So where are we starting at? We're starting at 1. And we're decreasing all the way down to what? What is this? This is going to be positive infinity. And you put the x in the middle, and then bam, bam, bam. That's how you do that. All right. So that's kind of like a little refresher. So most importantly, understand that your axis of symmetry is x equals 1. Your x-intercepts, you should have 2 of them. Write them as points. These are points. And then you have your y-intercept, and your vertex is a point. All right, you guys can go ahead and start the assignment for today.